In this video, we'll be explaining two essential search algorithms in computer science: breadth-first search, abbreviated as BFS, and depth-first search, abbreviated as DFS. Both of these algorithms are examples of uninformed search algorithms, meaning the algorithm has no information about the goal state except for the structure of the problem itself, but we'll explain this later in the video. We'll first examine how each algorithm works, and then analyze specific scenarios where BFS or DFS is more efficient. Depth-first search picks a direction and dives as deep as possible down a path before backtracking. Now, what does this mean? Let's use a hypothetical example to help us explain. Imagine you've arrived in a large city with many cool spots to visit, and your goal is to visit a specific spot. Let's say a really cool hidden garden that your friends have told you a lot about. The city has multiple roads and intersections that lead to various destinations. But since it is a hidden garden, the only way you can find it is by using a special map that only shows the location of cool spots but doesn't show what those cool spots are. But let's say that the garden is hidden at cool spot number 10. All you know is that there are several tourist spots spread across the city. Some spots are closer to your hotel, while others are far away. When using DFS to explore the city, you focus on following a single route from your hotel as far as possible, even if it takes you far from the city center before turning back. Here's how DFS would work for finding the secret garden. You'd first start at your hotel and pick the first road that leads to the nearest spot. Let's say you take the road that leads to the first spot, which happens to be a museum. You visit the museum, but it's not the hidden garden you're looking for. The next step would be to keep on going deeper and travel further down the road, after which you end up at the art gallery. You still don't find the hidden garden, so you continue even further down the next spot, perhaps the old cathedral. DFS will make you follow this route, taking you deeper and deeper into the city, checking one tourist spot after another along this path until you reach a dead end. In this case, it's the king's statue. You still haven't found the secret garden, so you'll drive all the way back to the hotel. This is referred to as backtracking in algorithms. Once back at the hotel, DFS will make you choose a different road, perhaps one leading to the local market, and again, go as far down that path as possible before trying another, repeating until you get to the hidden garden. As you can see, this method is quite tedious and could take a while if the hidden garden is on a completely different route. Now let's compare how BFS would work in this example. So BFS works by exploring all the nodes at the current level before moving on to the nodes at the next level. So BFS would focus on exploring all nearby points of interest before going deeper into the city. So you'll start at your hotel, just like with DFS, but instead of picking a single road and going down it, you'll explore all the nearby tourist spots within a short walking distance from your hotel, like the museum and the local market. Then you'll move on to the next level, where you'll explore the art gallery, old cathedral, castle, and lake, and then to the next level, where you explore the King's Statue amusement park, and finally, you'll find the hidden garden. So as you see, you systematically explore deeper into the city, checking every nearby spot first. So, in summary, what are the key characteristics of both search algorithms? DFS focuses on one route at a time and follows it deeply, covering all points on that route before going back. You might end up exploring a lot of unnecessary places far from your destination before finding the right one. But it's ideal if you want to thoroughly explore each path one by one, and if your goal state happens to be far down a path, like in this example. DFS is also memory efficient, since you only need to keep track of the points along your current path. In contrast, BFS explores all the points on the same level before moving outward to the next level. It might take longer to reach faraway spots since BFS will check every closer location first, but it is best at covering as much ground as possible, and if your goal state is not that far from the starting node. BFS requires much more memory than DFS, since you need to keep track of all the points at your current level. And the level of the nodes can grow exponentially in some cases. Thank you for watching our video, and we hope you enjoyed it.